So strategies for today are going to be to try to start with the more complicated side and make them look like the simplified side, or the simpler side. We're still going to be using our reciprocal identities, our Pythagorean identities. We'll be using our quotient identities, but we want to start with the one that looks more complex and make it simpler. And usually when there's a squared term, that's an indication that we're going to be using one of our Pythagorean identities. And if we have things with sines and cosines and tangents, so you oftentimes want to change them to just sines and cosines, is a good hint. Okay, good strategy. Factoring, seeing if we can get common denominators, those types of things. Difference of squares. All right, so the first example is to verify that the cosecant squared of theta minus the cotangent squared of theta over tangent squared theta cosecant squared theta is equal to cosine squared theta. It's not a bad idea somewhere on your sheet to write down your Pythagorean identities. Okay, so first thing we're going to do is decide which side looks more complex, and obviously it's the left side. So where do we want to start? On the top. What does the top look like to you? A 1, because if we get the cosecant squared minus the cotangent squared, we have a plain old 1. Okay, so this is nothing more than a Pythagorean identity. Okay, I like it. Now what do you want to do? Okay, the cosecant is 1 over the sine, so this is a sine squared, and tangent is 1 over tangent squared is the cotangent squared. Okay, so we use the reciprocal identities to get rid of that 1 over part. And then Dang is in the process of saying cotangent squared, so cotangent is cosine over sine, so the cotangent squared will be cosine squared over sine squared. Okay, we've simply used a quotient identity here. And then they cancel. Sine squared's gone. And so we are left with cosine squared. So they give you what you're trying to reach when we're verifying trig identities. And that was just simplify. Make sense? Questions on this one? All right, here comes the next one. Now we have 1 over the quantity secant of y minus 1 plus 1 over the quantity secant of y plus 1, and that's equal to 2 times the cotangent of y times the cosecant of y. So we have to decide which one looks more complex. Left side. So let's work with the left side. Good. Let's use the conjugate to try to make a secant squared minus 1. Why would we want to have a secant squared minus 1 in the denominator? You can use your Pythagorean identity. Exactly. Okay, so to get that conjugate, we have to multiply the left side, or the first one, by a secant of y plus 1. and the other one by a secant of y minus 1, and that will get us a secant squared y minus 1 in the denominator when we FOIL those out. Okay, and on top, we'll have, by getting this common denominator, a secant of y plus 1 plus a secant of y minus 1. So we get a common denominator, and then we also FOILed this out. We simplified the denominator. Okay. So now we recognize that secant squared y minus 1 as the tangent squared, right? Okay. Denominator is going to be tangent squared by a Pythagorean identity. So secant of y minus 1 plus 1's gone, right? So that was just simply combining like terms or simplify. The minus 1 that was on the bottom, this whole thing is the same thing as tangent squared plus 1 equals secant squared, one of our identities, because we brought the 1 to the other side to get this, the tangent squared. So we're just substituting all of that for tangent squared. Okay. So now what do we need to do? We need to be that so long on that one. Getting close. Okay. The tangent squared is in the bottom, right? So this is like 1 over tangent squared. Could we bring it up to make it a cotangent squared? Okay. So this is like 2 secant of y times the cotangent squared of y. That's just a reciprocal identity. And secant of y is what? 1 over cosine. So we can say 2 times 1 over the cosine of y. We need one of the cotangents, don't we? But how can we write the other cotangent? Cosine over sine. So we use a reciprocal and a quotient identity here. And this is nice because they cancel, right? 1 cosecant and or 2, so 2 times the cosecant times the cotangent. And that was simply because of the reciprocal. Make sense? So in a way, these are easier than what we did yesterday. Yesterday helped prep us and plan us and prepare us for, right? But today is almost easier because you know what your end goal is, what you're trying to get to. And it kind of can give you some hints. Okay? All right, ready for another one? All right. So now we want to verify that cosecant squared theta minus 1 times cosine squared theta minus 1 is equal to a negative cosine squared of theta. Right? So good. Cosine squared plus sine squared is 1. So if we bring that 1 to the other side, it'll be negative, and that would make it a negative sine squared theta. Okay? So this first one is nothing more than cotangent squared. The second one is a negative sine squared. So we simply use Pythagorean identities. Okay. Good. Cosine squared over sine squared is our cotangent squared. Reciprocal identity. Absolutely. And what are we left with? Okay. Not too bad, right? Okay. Next one. I want to verify secant minus cosine is equal to sine times tangent. Left side kind of looks a little more complex, doesn't it? Not much. You know, usually subtraction, is that more complex than multiplication? I don't know. But we can work with the left side. All right, so what are we going to do? 1 over cosine. That's just a reciprocal. Now, will they cancel? So if I have 1 over 2 and I subtract 2, can I just cancel those and say 1 minus 0 is 1? No, it doesn't work. So what do we have to do if we wanted to common denominator? We got to get a common denominator here. So in order to do that, we would take a 2 over 2, right? And so we'd have 1 half minus 4 halves, right? Or 1 minus 4 over 2, negative 3 halves. Okay, same idea here. So our common denominator is going to be cosine x. So we need a cosine x in the bottom. Yep. So now we have a 1 minus cosine squared x over cosine x. That's simply common denominator. Top is sine squared. That's a Pythagorean identity. Good. We have a sine of x and then a sine of x over a cosine of x, which is the same thing as tangent x times that sine of x. So we basically, I don't know, split and then used a reciprocal identity, quotient identity. Make sense? You're quick learners. Okay. All right, here comes the next one. Last one. Now you have to decide which one looks more complex. This time it looks kind of like the right side is more complex, doesn't it? So we want to do our simplification of our right side. So what suggestions do you have? Yes. Almost itself. Let's do not itself, but the conjugate kind of thing, the opposite. I like it. Okay. So because we don't have a common denominator. Common denominator means we have a sum or a difference on top and a single entity on the bottom. We can't use that. We can't just split them. So let's take this times a sine of a secant of theta plus a tangent of theta. Because when we use that, we get, it's like the difference of squares. We can back factor it. All right, so now we've got cotangent of theta times the secant of theta plus tangent of theta over secant squared minus tangent squared theta. Okay, so we did simply a multiply by 0, or multiply by 1. So what is the secant squared minus tangent squared? That's a 1. So now we've eliminated our denominator, haven't we? So we can distribute that through, right? We'll have a cotangent times a secant plus a cotangent times a tangent. Good. These are reciprocals. Cotangent's 1 over the tangent, so 1 over the tangent times the tangent is just a 1. Okay. What is cotangent as a quotient identity? Cosine over sine. 1 over sine. So we're using the quotient and reciprocal identity. Okay. Oops, and thank you. Miswrote. Secant's 1 over cosine. Don't forget our little plus 1 that we got hanging out here. Okay. That's from these guys. Cotangent is 1 over tangent, so 1 over tangent times tangent is plain old 1. We don't want to lose that guy. And then drop the cosines. 1 over sine is cosecant. And that's what we're trying to get to. So that was just simplify. Not too bad, right? Question. Okay, so then we said, guess what? We've got cosine in the numerator, cosine in the denominator. We're going to cancel those guys. We're left with 1 over the sine, and that's the cosecant. Okay. Other questions? Feeling good about these? Okay. You have a big whopping 6 problems to do tonight. Okay. So they won't take you very long, but it's more practice of this type of thing. Okay.